And weren't there regressions on your calculator?
Yes, there were.
And what were regressions doing?
They gave an equation.
They were giving you an approximate equation that would fit the behavior of the data. True. So data, it's like real world gathering of evidence or of observed results, whether in business or whether in physics or whether in like movement, motion, population behavior, polling statistics, who knows. If you're trying to look for a trend, you gather a lot of data and then you see if there's a mathematical model that can kind of show where it's headed, what it's doing, how it's going to behave in the future. It's called prediction. Hey, is there anything in life where prediction could be useful?
Yes.
Give me one. Yeah. Okay.
Stocks market.
Gambling, like what's going to happen in the game. I mean,
Stocks
not
market.
Exactly advising, but that's a smart thing to do. But what else?
The stocks market.
Stock market, yeah, definitely the stock market.
When you're playing a sport.
When you're playing a sport, oh, like thinking of stats.
When you're playing Fortnite.
Predicting how you're going to perform, how the other team is going to perform, the strengths, the weaknesses, right?
Or like predicting what the other team should do.
Yeah. What else?
When you're taking a whack test.
That's not prediction. That's
Sure,
cheating.
not sure.
That's cheating.
I was thinking weather reports. Anybody ever look at those? They're always right, but they try.
Oh, they predict.
Yeah, they're predicting what the weather's going to be like today, tomorrow, right? Okay, so predictions. There's that app. Well, actually, that's, I think, just the measurement. But the app that says, like, an earthquake's coming. You guys know that they have the instrumentation where you have the app on your phone where they start to see the...
Oh.
There's, like, the app that's, like, the earthquake.
Ouija
That's
board.
not mathematical. Anyway, coming back. Neither is, like, the shaking the 8-ball.
The 8 ball.
Used to be a thing. So... If we were to try to,
Right?
we're done. We digressed into something that's not. Although I did get one the other day that said that I should pursue my dreams of traveling abroad.
See, it's a prediction.
Not because it told me so, just because it had a try. So, could you possibly have something moving, behaving in a wave-like fashion? Yes, and if you were to run a regression, it would actually turn you to sine or to cosine, or to some sort of weird polynomial that wouldn't work forever, because polynomials always do what? What would an even degree polynomial, even though it might have lots of Humpty Dumps, what would it eventually have to do? An even. It would that's odd. It would eventually have to go to forever or go to negative forever, and what would an odd, even though it might have Humpty Dumps, what would an odd always have to do? Yeah, positive, negative. Okay, so even though polynomials have Humpty Dumps, they don't keep waving like sine and cosine does. So anyway, we're going to come back to this in just a second, but you guys, before we leave this page to go grade 10 work, can you write down for me y equals sine of x? We would do theta, but remember our calculator uses x, so it doesn't have to be theta, just that's what we normally do. And cosine of x. If you were to go put this into your graphing calculator in the y equals menu, you would see waves. Now, baby waves, because look at how high and how low this normal cosine and sine go. How high?
1.
Yeah, just up one, down one. Wait, that makes sense. How high does sine and cosine go in the unit circle?
1.
Up to 1, and then it could have been negative. So it's not going to be a very big wave. Oh, but wait, maybe in real life it's not just going up to 1. Maybe the wave, like the rock was big and the ripples are big, or maybe the actual waves coming in from the ocean are bigger and smaller. It'd be nice if we could make cosine or sine stretch. How could we stretch a sine or cosine mathematically? Not adding, but I know what you're saying. Multiplying a coefficient, right? We could change the amplitude. Hey, sound waves, amplitude, amp it up. That's the thing. Amp it up. Make the sound waves taller, louder, right? Amplifiers. Oh, that gets interesting. Anyway, amplitude. We're going to be playing with these waves to make them practical for what we're using them for, which won't be near as complicated as the real life stuff. But at least it kind of gets us introduced to them. Okay, but before that, Ooh, we need to talk about the unit circle quiz. But for right now, we have to first grade. Oh, people who were gone on Friday, you should watch the video. There was a cool hand trick to the unit circle. Anyway, section 4.4 homework. Let's grade. Okay, color pens out. Section 4.4 homework. It was the one that was due, I think, this morning. Is that right?
Yeah.
Man, tons of evens. We better go look at it. Section 4.4 had to do with trig functions of any angle. Lots of trig functions. Sometimes not even unit circle because it was like bigger, wider stuff, but that was okay. We just made triangles out of it and did good old-fashioned Sokotoa Choshiko and didn't even think about the unit circle. But then there were some unit circle ones where degrees and radians would have helped. All right, so many evens. Let's grade. There was only one. Remember 8 was reference.
What?
The rest were odds.
So there's no correction.
Well, there's one.
Well, don't you have
So if you got them all right, because you turned to the back of the book and you made sure that everything was good, make sure in a colored pen you put a check mark, otherwise my TA and or myself will not know that you graded this homework. Yeah.
It feels weird to do it.
Okay, do you guys grade? That was hard.
I don't care.
Grading's done, but any questions? Any places we got stuck? Any places we got stuck in homework? Perfect. Back of your homework spirals, or go to a blank piece of paper. Ready, set. Back of your homework spirals. Don't worry, it's not a quiz. It's in your homework spiral. I'm just gonna act like it's a quiz. So you're gonna grade it with your colored pen for future information.
So we're going to
You ready? Just a blank piece of paper. Oh, don't worry about that. Here, I'll have it. Nope, that's not. I mean, that would have been great, but some of you don't think in the table. There you go. Ready? 1, 2, 3. I just want you guys to fill in the current answers. No discussion. Do the best you can. Use a circle, use a triangle, use a cheat chart. Whatever you need to find me. Sine of 5 pi over 3. Tangent of 2 pi over 6. And secant of 5 pi over 4. Don't worry, no grade is getting attached. This is just a learning opportunity of do you know the unit circle and how the way that works for you. Without notes, without calculator. Can you build it? If you're not sure, try to think of what the possible answers could be. And pick one. If you're not sure, think of what the possible answers could be. Pick one. 5 pi over 3, pi over 6, and then 5 pi over 4. normal quiz, I would probably give you a little more time. But this is just to know if you're heading in the right direction and if you have a way. So basically have a little bit more time. 1 more minute. Best you can. Best you can. Best guess. Waiting for 2 things. The correct positive or negative. So worst comes to worst, guess the positive, guess the negative. So if you leave it blank, I can't even give you points for the sign. SIT. Looking for the positive, the negative, and the number.
You need to look.
30 more seconds. Best guess. How do I know this guy has to be a negative, this guy has to be a positive, and this guy has to be a negative? What quadrant the angle lands? Good. And knowing things like, well, maybe who sine is, cosine is, tangent is. That's one way of knowing who they are. Right triangle ratios of sides, right? Opposites, hypotenuses, adjacents. Sine, cosine, tangent, cosecant, secant, cotangent. That's one way of knowing who they are. Another way of knowing who they are has to do with little ordered pairs in unit circles. And there are formulas built off of cosine is the x, sine is the y, tangent is the y over x, cosecant is the 1 over y, secant is the 1 over x, and cotangent is the x over y. Sorry, my brain doesn't think like that at all. But that is one other way of thinking about it. But before we can even get to all of that stuff, we have to at least somewhat have an idea of the quadrant. So you guys know all students take calculus, right? But that doesn't exactly help if you can't get in the right spot. All are positive, sine and his guy is positive, tangent and his guy, his cofunction is positive, cosine and his cofunction is positive. So, or his reciprocal, I should say. 5 pi over 3, where did that land? How do you know it's the fourth quadrant?
Oh, so 3 over 3 is 1 pi.
Good. 3 over 3 is 1 whole half circle, right?
You should have to put it in the
So 3 over 3 is 1 full calzone. 6 over 3 would be, if I had 3 and 3, that'd be 6, but I'm 1 shy, right?
Yeah.
So I can go 1 shy. Okay, I'm 1/3 shy. So I'm in the fourth quadrant. And why do you think it's so steep and so down? What's the reference angle of a pi over 3? How far from 180 is it? Pi over 3, which corresponds to what degree? What's 1/3 of 180? 60. Anytime you have an over 3, you can think in terms of 60s. So if it helps you, my degree people, 5 60s. You could literally think of 1/3 of 180, like a quick little conversion. Why am I doing this? Different ones, you need to visualize it different ways. If you were doing like a little conversion, you would get 60 degrees. So 5 60s. 60, 120, 180, another 60, 240, another 60, 300. Maybe you need to think of this as being 560 degrees. Maybe. But either way, I'm in this little triangle. And if you can visualize a triangle, whether or not you have this memorized in the unit circle, do any of you guys think in terms of Emily and me? Or I should say little and big, right? The x, The adjacent, the cosine is going to be the little, 1/2. The sine is the big, it's going to be root 3 over 2, but it's going down. That's one way. Either having the ordered pair memorized and knowing the y, negative root 3 over 2 goes with sine, or thinking of the movement. Cosine's a little, sine's a lot. Cosine is always the adjacent one, sine's always the opposite one. Or, what's going to cover up over here? Isn't this just 1, 2, 3, 3, 2, 1, all over 2, square root of 3 over 3, 1 square root of 3. Bum, bum. Where's pi over 3? Because it's a pi over 3 reference angle. Here. What sign? 3? No. Remember you have to put a little square root and do it over 2? Oh. You just could have stolen it from there. So if you write this at the beginning of your quiz, if you have this memorized to be able to write, couldn't you just use it the whole quiz long? It's not cheating if you write it once the quiz is started. Yeah, some of you are. So, the pi over 3 is root 3 over 2, but it's a negative. I know, because it's in the 4th quadrant. It has to be a negative. Sine does anyway. Do you have a way? Are you good at the circle? So you're going to draw a quadrant of the circle and copy it around and just steal from the x and the y. Sine is the y in this quadrant. Are you good at triangles and moving littles and lots and having that matched up with the 5 answers that sine and cosine can be? The littlest, aka nothing, and then small, medium, large. Think Goldilocks. I don't know. Too hot, too cold, just right. I don't know. But these are the numbers that all the sines and cosines are going to be. Sorry, counting up, counting down. I didn't finish. There you go. Okay, either way. How do I know this one's positive? It's in the it's in the first quadrant, yeah. So it had to be a positive. Guys, when we take you circle quizzes, we're taking 2. One is tomorrow, it's your first try, and you get a second try on Wednesday. You won't get a lower grade on Wednesdays if you do worse on it, but you have a chance to make Tuesdays better. Just kidding, Wednesday and Thursday. It's Tuesday, man, that's what happened there for me. I give you a point for having a positive, even if you don't have a number down at all. Yeah. I still have you take it Thursday just for the practice of, can I keep or hold on to it more than one day? And some people study for a quiz and forget. But your grade won't go down. Does that make sense? Okay. And we'll grade them like right away in the sense of like I'll collect them, show you what the answers are, so you'll know right away. So yeah, Friday, Thursday will only help you. Man, days of the week. You should just see. So we know that tangent's positive, pi over 6. But my triangle movement, people, it's opposite. So the little one over the adjacent, the longer one. So it's going to be 1 over root 3, or 1/2 over root 3 over 2. But then to make it match necessarily, you would need to get that root 3 over 3 as your final answer. My cheater sharp people, square root 3 over 3. Oh, it's the first one. I sing a song for these weird in-between ones, and I use the points on the axes for the outside ones. I only did 3 questions, guys, so I didn't do any of the axes ones, but you know from homework that these show up also, the 3 pi over 2, the pi over 2, the pi. So be ready for those also. I'm just doing the in-between, but I love the line and the jingle for tangent, because my brain knows square root of 3 over 3, 1 square root of 3, and I don't have to do any work. This is a pi over 6, he's a 30 degree, he's the first guy. Square root of 3 over 3, I'm done. And then secant. Ooh. Well, first of all, what quadrant? How do I know if he was negative? 4 over 4 plus 1, right? So halfway plus 1, he's in the 3rd quadrant, yeah? Oh, everybody in the 3rd quadrant is negative. Well, not everybody. All students who could be a positive. Tangent and cotangent. But, yeah, odds are that your guy's going to be negative. And if you know tangent and cotangent, secant's not that guy. Now, who is he the reciprocal of? Now, over 4s are nice because it doesn't matter. Right? Aren't they both root 2 over 2s at those 45s? That's kind of nice. But the sign still would matter if you were in a different quadrant. So secant is cho, sha. Is the middle, just like cosine. E flips cosine. Whoop! No, that's way too nice looking. Did any of you guys think of flipping root 2 over 2 and get something a lot nasty?
69.
If you flip root 2 over 2, wouldn't it look like this? So why isn't that my answer? Because you gotta rationalize it. Alright. 2 root 2 over 2. The 2's reduce. There's a negative somewhere in there. Boop, boop. There you go. So there are certain things that kind of help you out as far as answering these quicker. Like I know that root 2 over 2 is actually this guy, just written nicer. So if I ever need to flip him, I just flip that guy. It's easier in my head. There are some little tricks like that. Or I know that if I ever need to flip root 3 over 2, I just know it becomes 2 root 3 over 3. Sorry if I need to flip it. I didn't flip it. But there are some weird things that can kind of show up that's not quite as nice and straightforward as these 5 little dudes. So you could kind of think of, let's see, flipping him would be undefined. Flipping him, flipping him, flipping him. Some of you are just memorizing people. So these would be all of the possible reciprocal. These are all the possible secant and cosecant values. Guys, I just had lots of different students and they do lots of different things. Some of them use triangles, some of them use circles, some of them use some weird morphing of them together. Some of them always do the cheater chart. Some of them actually like literally memorize every single possible combination you could ever get. And it works for them. I would never want to do it because my brain's too lazy and I like finding patterns and using them. My question to you is the same one on Friday. Do you have a unit circle way that works? Or do you have one that your brain tends to like better that you need to study? Right? You gotta pick one. If this entire quiz you're like, I have no clue. And as we graded it, and as I talked through different ways of thinking about it, you still have no clue. Please come in, just let me give you a whiteboard and we'll figure out a way and then you can study that way. If you're like, okay, I know which way I want, I'm just not good at it yet, come on in with a whiteboard today or tomorrow. Remember, we're doing part 1 or take 1. Take 1 like a movie, right? Take 2, take 3, take 4. Take 1 is tomorrow. Do the best you can. Maybe you get 100. Awesome. You're going to have a take 2 on Thursday. You have 2 chances. I'll pick the higher of the grades as your quiz grade. Sound good? It's going to be 5 questions plus a bonus.
It's really like that. You won't be filling in.
No, not filling in. Because I don't want to make you choose a way. I just want you to have a way. Is that cool? So it's going to be like this, but 2 more questions. And then a bonus. The bonus is probably like something that goes beyond 2 pi, so like a coterminal angle that makes you think a little bit harder. Or the bonus could be like a weird axis one. But I'll probably have a 30, a 60, a 45, and probably an axis, and then maybe 1's repeated. So yeah, I think 5 questions. Because I try to make it so that they're worth at least a little bit each, but without like, you guys know, if you miss one of these, wouldn't you like get a 60%? Yeah. Oh wait, but I'm counting signs and numbers. Okay, so these aren't really 3 points, these are 6 points, right? But if I have 5, then it's 10 points, and so each of the signs will be worth 1, and each of the numbers will be worth 1. Do we at least have an idea of what's coming? Okay. So anyway, unit circle quiz, you guys are going to have 1 tomorrow, you'll have another one the next day. And they're going to be at the exact same format, just different angles. And I'm just going to kind of throw random ones. So, have a way. If you don't have a way, come find me. Alright, cool kids, we are in section 4.5 talking about waves. But why? We've been talking about trig. Why is it waves? Because waves are trig. But not all the trig. There are 6 trig functions. Who are we talking about in section 4.5?
Sine, cosine.
They are the only waves. Everybody else is a little bit different. Cosecant and secant, we're going to use these graphs, the sines and cosines, because you use sine and cosine trig ratios for cosecant and secant. So the nice thing is those graphs will build right off these graphs, which is really helpful. Tangent and cotangent, is that you? Those are just weird. Those are in their own little category. But the waves are going to help us for 4 out of the 6. That's pretty important. So you guys have gotten things down, hopefully, like up 1, down 1. So up to 1, down to -1. Sorry, the negative got kind of squished in there. Can you guys tell what the radians are?
No.
What's one full rotation or revolution of the unit circle? 2 pi. 2 pi is full, so where would half of that be? Pi. Where would half of pi be? Pi over 2. So I have 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Got it. It's just units. So is there like a pi over 4? Yeah, somewhere, but he's a weird decimal. 2 over 2 isn't a nice number. Is there a pi over 6 in here? Yeah, he'd be like over here somewhere. Pi over 3 would be in there somewhere. And then there's ones of those for each quadrant. Wait, each quadrant? 0 to pi over 2 is quadrant 1. Pi over 2 to pi is quadrant 2. Pi to 3 pi over 2 is quadrant 3. 3 pi over 2 to 2 pi is quadrant 4. These are actually quadrants in the unit circle. Huh, I wonder if the wave would help me remember stuff. Like, sine goes up and then down. 1, 2, 3. Huh. Whereas cosine goes down. 3, 2, 1. When is sine equal to 0? Oh, here and here and here. When is sine equal to 1? Oh, and that's a -1. Anyway, the waves can actually be another study tool for the unit circle, but maybe I'm just throwing too much at you and I should just be quiet. Shape of graph. Wave. Yeah, you're right. But there's a snazzy adjective for it. It's called a sinusoidal wave. Sorry, I have to learn today. A sinusoidal wave. We can actually call the wave itself for sine and cosine a sinusoid.
Sounds like a mental disease.
Doesn't it? I think it sounds like I'm from New York. Sinusoidal. I don't know. Anytime you put an oi in something, it sounds like you're from like Boise. Anyway. So we got ourselves some sinusoidals. For sine and cosine. Wait. They're both called the exact same thing? I don't get it, but they're two different trig functions. Wait. Isn't he a sine and he a cosine? They're related. And they're both waves. What's different? Co and then sine. Co-function. Cosine is a co-function of sine. Anyway, they're the exact same thing, just shifted. Oh, we knew that. 0, 1/2, root 2 over 2, root 3 over 2, 1, or 1, root 3 over 2, root 2 over 2, 1/2, 0. Oh, they're the same thing, just shifted. So, they both have the same shape, just shifted. So if I wanted to find sine in here, I could. Sine could be right here. He could be in this cosine curve, just shifted. Or cosine could be in here, just shifted. Anyway, something to keep in mind. But for all of these waves, there are key points at all the maximums and the minimums, and technically everywhere in between, but specifically at the intercepts. Okay, now I'm going to go ahead and zoom in over here. I'm talking about these key points. Got him. Which is going to be super helpful and useful in sketching and transforming. Do you guys remember when we transformed absolute value functions, or cubic functions, or parabolas, or, when we were transforming, especially ones like e to the x, and ln of x, and log base 5 of x, and 7 to the x, if you were transforming those, didn't we talk about having like some key points to move and shift and flip and stretch and all that jazz, right? Like parent functions had key points, and you could do the transformation to those key points. Oh, remember number 9 and 10 in homework, the one where there was the graph just with the points, and you had to change the points and move them where you needed them to be, and there were 7 different transformations, 6, 10, I don't know, there were a lot. Key points are super helpful in waves also. 5 key points. Do you see them? At the max, where max is. At the min, or mins, and at the zeros, or at the intercepts. So the max, the min, the zeros. The max, the min, the zeros. That's the 5 key points. The top of the wave, the bottom of the wave, and the middle of the wave. Now, the nice thing is every wave behaves the same. Whether you're starting in the middle, whether you're starting at the bottom, whether you're starting at the top, it goes in, right? Traveling down, and then up, and then down again. So we're trying to mark our key points. Hopefully we can kind of get the pattern, get the flow of what the 5 points are. But hold on, wait. If there are 5 of them, why are we cutting the period, how long it takes for a cycle to complete? Why are we taking the period and cutting it into fourths? How does that make sense? There's 4 things. 1, 2. There's 4 portions with points marking the beginning and endings of them, right? So technically, if I was to put like a little axis, which isn't always there, but if I was to put like a middle of the wave, which is always there, I could section this off into, check it, there's going to be 5 intervals, but only 4 sections. 5 intervals, but only 4 sections. Because check it, if I was to start here, here to here is 1 section, 2 sections, 3 sections, 4 sections. There's 5 tick marks, but there's only 1, 2, 3, 4 spaces in between. So that's why we're able to say that we're going to cut that period into fourths. Oh, like the 4 quadrants. Okay, that makes sense. We could go to Revelation. It's kind of weird and random and not. Anyway, beep, beep, beep. What am I missing? 1, 2. Oh, yeah, I did need that guy. 3, 4. Okay, but hold on. Wait. Does every single transformation need this huge, crazy process that's about to come? No. Because what's the only transformation that happened in this guy?
Vertical.
Yeah, vertical.
Vertical
Stretch by a factor of
2.
This sine wave has been amped up, right? The sound was turned up.
The base is something.
So instead of going up 1, it's going to go up 2. But other than that, I'm still starting in the middle. I'm still getting to 2 pi. Nothing was changed horizontally. So I have 1/2 pi in the first quadrant, then pi, and then 3 pi over 2. That's going to be the same. Just instead of going up to 1, now it's going to go up to 2. Because this guy goes up to 1 times 2. Oh. And he's still going to go to 0. He's still going to go down, but he's going to go down to -2. And then back up. Can we draw this guy? Yep. Wait, but they totally say to go to 4 pi. Oh, it's a wave. Don't waves repeat, guys? So if I want to go to 4 pi, what do I need to do? Just keep going by halves. And so that's 1/2, 2 halves, 3 halves, 4 halves. Here's 5 halves. And then 6 halves. I think that reduces maybe just a little bit. And then 7 halves, and then 8. Anyway, keep on going. But yeah, you just keep on going. And if they want me to go the other direction, to -pi, okay, fine. Just keep your units equal. Keep your units appropriate. The nice thing with waves is, ready? Here's what we're going to do tomorrow. As long as we can figure out how high it goes, how low it goes, where the middle is, if we know how high, and if we know how long, all you do is top, middle, bottom, middle, top, middle, bottom, middle, top, middle, bottom, middle. It's not going to be bad, but we have a few things to do. Unit circle. Unit circle. And to be honest, I would probably leave homework. Sorry, that's a bunch of that. Always the last 2 quizzes. But not the unit circle, right? No. Okay, good.
No, like I say.